Okay, this is a continuation of 3-3 rotations, practice and problem solving. Okay, so we are at number 8, I believe it was. Yeah. Okay, so this question says, Lourdes created the design below by rotating triangle ABF, quadrilateral BCEF, and triangle CDE. Describe the rotations she used. How do you determine the angle of rotation? Okay, so on the right-hand side, we have this prompt. It says, Lourdes rotated triangle ADF blank times about point blank. So let's take a picture here. Okay, so first of all, let's identify the triangle it's talking about. Triangle ADF is this triangle right here. Okay, and then you can see what they're talking about, it being rotated several times. Because if you rotate it a little bit this way, it'll land on this part right here. Okay, and if you rotate it a little bit more, it lands right here. And if you rotate it a little bit more, it lands right here. So when you rotate this a few times, you can generate this pentagon looking shape. Okay, so it says, Lourdes rotated triangle ADF blank times about what point? So it looks like we rotated 4 times. Whoops. So here's the first rotation. Here's the second rotation, right? Each arrow was showing a rotation. 3 and 4. So 4 rotations created these 5 triangles. So the answer here would be 4, and for this one it would be around. Okay, so we have to say around what point. So we were rotating around the point A. As you can see, the arrows I drew, they sort of kind of making a circle. And I think by this time you guys know that rotations, when something is rotated, it draws out a circle, okay? And it draws out a circle where the center is the point of rotation, or sorry, the center of rotation. Okay, so this would be around the point A. All right, the next sentence says, since there are blank degrees in a complete rotation. So what they mean by complete is like all the way around. Okay, so that would be 360 degrees. Okay, so this is 360. Since there are 360 degrees in a complete rotation, the angle of rotation can be found by dividing blank by blank. So what they mean by the angle of rotation, they mean this angle that I drew at first. So here you have the triangle, its original position, and then it gets rotated 1 time so that it lands in this second, on the second triangle. They want to know how many degrees that is, how many degrees of rotation that is. Okay, and the way they're wording it here, it says the angle of rotation can be found by dividing blank by blank. So what they want you to realize is that it's being rotated the same amount every single time. And there's a total of 360 degrees around. So if you divide 360 degrees all the way around by the number of triangles that you see, which is 5, then that tells you how many degrees it took to rotate around to each one. Okay, so let's do 360 divided by 5. This is 72 degrees. So it takes 72 degrees to rotate this triangle so that it lands where the next one is. Okay, because it's it's the same number of degrees each rotation. So the rest of this is the angle of rotation can be found by dividing a full rotation, 360, divided by 5 different triangles that we see in the picture. Thus, every time the triangle is rotated, it rotated 72 degrees. Whoops. Okay. Let's go to number 9. Okay. Number 9 says quadrilateral J prime, K prime, L prime, M prime is the image of JKLM rotated about point P. Select all true statements that describe the relationship between JKLM and J prime, K prime, L prime, M prime. All right, so this is a really good question. This is the type of thing I'm likely to put on a quiz, like one of our that we're going to be having soon, one of our exit tickets. So let me go ahead and take a picture, hopefully without that box. So let's just go ahead and draw out a scenario really quick. So let's just pretend it's on the coordinate plane to make it a little more clear. Let's say the point P is the origin. And let's say that it's got 4 letters, right? Well, actually, it did say quadrilateral, so it's some kind of quadrilateral. So let me try my best not to draw like a nice regular quadrilateral. So let's draw something strange like that. But it's got 4 vertices. 1, 2, 3, 4. Okay. And we'll go ahead and give them the names. So let's put J over here at the corner, far away from the other ones. J, K, L, M. And let's just pretend we rotate at 90. So this is, I know this question is not asking about a specific rotation like 90 or 180 or anything. But if we can just get a little picture, that'll give you guys a little bit of instinct on what, which of these might be correct for any rotation. So let's pretend we're going to rotate 90 degrees. So we're going to rotate 90 degrees clockwise. So if we rotate 90 degrees clockwise, this line here, JM, is going to end up being vertical. So maybe something like this. So this will be J, this will be M prime, J prime, M prime. And then this is slanted a bit. Sorry guys, trying to make it accurate. It's probably not that important, but okay, so that'll be J, M, and then this will be L prime. Whoops, the other one. L prime, K prime. So this is rotated 90 degrees. Okay. So let's go ahead and read these different options and try to figure out which ones must be true. So the first one says the measure of angle KLM. KLM is this angle right here. They're claiming it's going to be the same as J prime, K prime, L prime. J prime, K prime, L prime is this angle right here. There's no reason why those two would be congruent. Okay. In fact, if you look at JKL in the original, this looks like it might be close to 90, perhaps. Okay. But, and, this one is obtuse. So, they're not really related at all. Okay. Claim B is that J prime, K prime should be congruent to JK. Okay. J prime, K prime, which is this line segment here with the green dash is congruent to JK. That is true. And that's because those parts actually correspond in the pre-image and the image. And so we know that a rotation is a type of rigid motion where all the angles and all the side lengths stay the same. So this one is true. C says LM is congruent to JK. That is not necessarily true. So LM is this line segment with 2 dashes, and JK was this one. It's obviously much longer, and they're not asking if it could have been drawn in a way so that could happen, so that they were congruent. It's asking, does it always have to be? And the answer is no, it doesn't have to be. When I first tried explaining this problem, by mistake I drew rectangles, and a lot of the things in a rectangle are congruent, like opposite sides are congruent and stuff, so it made for a really terrible example to try to teach you guys this question. Because a lot of things were actually coming out congruent, but it's just because I chose to do a rectangle. But these types of questions, we're going to run into these all the time. It's asking, like here it says, select all true statements that describe the relationship. They mean like true every single time, no matter how you draw it. Okay, and we did an activity the first day of school where we tried to draw something with a very simple description, and you guys all came up with a bunch of different ways to draw it. So it has to be true no matter how you draw it up. So C is not true. Option D says K prime L prime has to be the same as ML. That's not true. There's no reason why 2 different line segments that don't even correspond would have to be this congruent to each other. And then the last one, which is very important, is that the measure of J prime K prime L prime is equal to the measure of JKL. So this one is true. Let's go identify those angles. So J prime K prime L prime, JKL, that would be this angle right here. They're claiming is equal in measure to JKL. That's this angle up here at first. And that's true because those two actually correspond to each other. That's the same angle, it just got rotated around to this end over here. Okay. So that means that the last one is true. So B and E, at least the way they ordered it on my question, are true. The last one says, a point is rotated 270 degrees about the origin. The image of the point is -11, 7. What are the coordinates of the pre-image? So this is asking where this point began rather than where it's going to land. It's asking where did it start before the transformation, before the rotation. Since the rotation was 270 degrees, so we got the point. We're going to rotate, oh, sorry, hold on. So we got -11, 7. This is where it landed after it was rotated 270 degrees, counterclockwise, by the way, right? If they don't specify clockwise, then we have to assume it's counterclockwise. If we want to know where it started, what we can do is rotate reverse in the other direction. We can rotate clockwise 270 degrees to go back to where it started. So that's what we're going to do. We're going to figure out what a rotation of 270 degrees clockwise around the origin, which is what it says there, right? Around the origin. This is one way to write that. Of this point that they gave us, the image. We have to figure out what that is. So, the rule for rotating 270 degrees clockwise is, I'll write it up here, 270 degrees clockwise around the origin is equal, of a point x comma y is equal to, let's see, clockwise negative y comma x. So hopefully you've gotten used to this already, but what this means is that you're going to actually switch the coordinates. So it's usually x, y. You're going to put the y first and the x second, and then we have to change the sign of the one that ends up in this first spot on the left. So we're going to take -11 and 7, and we're going to switch them. So the 7 is going to come to the front. The -11 is going to go to the right, to the second position. And then we're going to change the sign of this one in the front, which is the 7. So we're going to change it to negative. So -7, comma, -11 is the answer. So the answer is A.